Hello, audience. I'm Julie. What's your name? Everybody. All right, nice to meet you. Now we can chat. So I've noticed that there's a bit of a theme running through this conference over the last couple of days. David talked about the fixed idea and how ideas can get in the way of new ideas. And then this morning, Brian brought up an interesting point about debugging and how debugging is actually the process of better understanding your system, forming hypotheses and testing them. So I'm going to be expanding on that theme quite a bit. And then later, Phil talked about developers as researchers. So I didn't actually think of this in terms of research, but I think that these themes kind of mesh pretty well. So I've been a software engineer for about 15 years, and over the past decade and a half, I've come to rely more and more on my past experience to guide my choices. So if I'm coming up on a new project and I need to pick a programming language, I'm not going to go, oh, let me survey 10 languages that have come out recently and see which one to pick. No, I'm going to go, I know Scala. I know it works, so I'm going to go with that. But there's a tension here, which is that we live in we're working in a very fast-moving environment. And I actually became fascinated with Scala about 10 years ago, and at the time it seemed really frivolous and kind of, self-indulgent to get into it. I was really attracted to the functional paradigm, but I'm really glad that I did, because it did become mainstream, and the functional paradigm actually helped shape the way that I think about code and programming. So today I'm going to tell you the story of a classic dilemma that we all face, and that's the trade-off between exploration and exploitation. And this trade-off was made in a real sense at my company, so I'm going to get into that story. But first, I want to remind you, please give me a rating. Thank you all for coming at this late hour, so would appreciate your feedback to see whether it was worth staying for. So I'm going to start at the beginning, at the founding of my company. We started in 2014, and we are called Order of Magnitude Labs. So the founding team was myself, Greg Orzel, and Christian Kaiser. And we knew each other because we had worked at Netflix back in the early days, when Netflix was a DVD business and streaming was a hypothesis. And we liked working together enough that after splitting ways for several years, we got back and did another startup together. But we got to talking and realized, we can break off on our own. Let's try this. Well, the first thing we had to do was figure out what space we were going to be working in. And it didn't take long until we keyed into how much is going on in the AI space. AI is a big field, right? What do I even mean by that? Well, we were fascinated by kind of this sub-problem. I don't know that it has a name, but I'm going to call it intelligent machines. And what I mean by that is machines or agents that learn not from being force-fed huge piles of data, but that learn through experience and interacting with the world. And through that, our hypothesis is that they would learn to perform a multitude of tasks, common sense tasks, like communication, locomotion, foraging. So interestingly enough, one of the unsolved problems in this space is actually exploration. There's not a real good answer yet how to get machines to explore. And so hopefully if we can peel back the layers and understand how we explore, we'll be better able to build machines that can do the same thing. So we started out with a business hypothesis. After kind of a brief survey of the landscape, we had this hypothesis that the basic building blocks were out there to build these intelligent machines. And so all we needed to do was apply our engineering background to this problem. And we knew how to scale things, so that was good. And then amazing things were going to happen on the other end. So we set to work with prototyping. And we chose Scala. I listed all of these wonderful reasons why Scala is great, but going back to what I said earlier, the real reason was we used it and it worked. So we built several prototypes in parallel. And my first one that I was most excited about was this idea that, we're building a neural network. And neurons communicate through messages, and they have state. And I had used Akka before, which is an actor system for Scala. And so I thought, what better paradigm, because we're trying to scale this, right? So I built it, tried it out, and it didn't really work. It really didn't work. And so after examining why, what I realized was I didn't really understand the domain that I was working in. I understood the technology, and that distracted me from getting into the domain. So even though I knew I could do all these wonderful things, what I needed to do was slow down. So just because you can do something doesn't mean you should. In other words, when you're entering in a new space, cultivate a beginner's mindset, even if you have familiarity with some aspect of it. Okay, so we went on to prototype number 2. And this prototype was incredibly simple. A whole bunch of case classes, if you're familiar with Scala, it's just these immutable classes with some pure functions attached to it. I ended up presenting a version of this prototype back at Scala Days in 2015, so follow that link up there in case you're interested. Side note, little known fact, I didn't randomly pull this image off of Google image search. This is actually my spouse here messing around on his son's bike back when he was little. Anyway, so we built that prototype, and that kind of worked, but it didn't really work. And since we had thought more about the domain, it started to dawn on us that there was this disconnect between our business hypothesis and the reality. We thought that we had kind of this neat journey of climbing this hill. We knew how to climb hills, we're engineers, but the reality turned out to be that we needed to survey a landscape and determine, well, which mountain or mountains should we try climbing to even figure this out. So we're kind of at a crossroads. And we have to decide at this point, this isn't what we originally thought, so should we do it or go do something else? So Greg, one of the original founders, said, he was a very sensible guy, and he said, I didn't sign up for this. So he ended up doing something else. Christian, on the other hand, was really enthused about this problem and thought, I'm not ready to give up yet. Let's give it another shot. So I had to think about this. Aside from being just really passionate about solving this problem despite not knowing a lot and just wanting to see it solved and the value that that could create, I also had a personal endeavor in mind. And that is, as a child, I was more like the kid on the right. I was very just artistic and creative, and at some point along the way, I discovered math and computer science. And I loved those disciplines. I loved the orderliness of it. I could understand it. And so I became more and more like the kid on the right. So I knew that somewhere buried was this artistic person, but I felt like that person had been neglected. And I thought, okay, what better way to get back in touch than to try something kind of crazy? Okay, so little did I know that what I was doing was evaluating this amazing formula that we believe all of us must optimize in order to choose a course of action. So formally, this formula is known as negative expected free energy, and it was formulated by Professor Carl Friston. But don't worry about that fancy title, and don't worry about these symbols. The big point about this value function is that it includes two terms. It includes exploitation, which is the value that you get out of performing a course of action that you already have modeled, that you've already mapped out, versus the value you get from the information you might gain through exploration. So let me just put it into more of a schematic form, and this might illustrate why exploration is so hard as we get older. At the end of the day, the more experience you have, the more sophisticated your model of the world is. And the easier it is to predict some course of action that will reliably reach the goal that you're after. So if you know something that works, why would you try some other things that may or may not work? So how do we flip the teeter-totter the other way? Well, we have to convince ourselves that the knowledge that we would gain through this exploration is going to lead to better and better outcomes in the future. It's intangible. We can't really quantify that other than kind of recalling other experiences we've had where we explored and actually gained something. So I decided to do this, but it wasn't as easy as I thought. I had to shift my mindset to explore. So here's where I was starting from. This is kind of my view of the world at that time, which is that no problem is unsolvable when you apply engineering best practices, right? You're on this side, everything's going wrong. The engineering best practices build a lovely bridge across the lava pit, and everything is great, right? And so I thought, okay, I can engineer my way through this problem. And I kept doing that, and it really didn't work. It took me an embarrassingly long time to realize what I was really optimizing for with those engineering best practices. It's all about building to a spec. Yes, the spec changes, we know that, but at least there is one. I was optimizing for shipping code and operating, a server farm, let's say, minimizing tech debt. But in reality, in this space that we were exploring, these things were not terribly important as kind of first-class goals. So here's what I should have optimized for. Should have optimized for formulating hypotheses, testing them, and then rejecting the ones that didn't work out. So I had to learn a few lessons about how to best go about that in a software setting. I mean, the first thing that was really jarring for me was that facts can change. And yes, I kind of knew that at some intellectual level, but this was really driving at home. The other thing is you're working in a laboratory, not a factory. And you have to think about how to outfit your laboratory. And then the third thing is, how do we communicate and work together as a team to push this process forward? So let's get into each one of these. As far as facts go, I remember many occasions, Christian and I would be having some kind of very animated discussion about some technical aspect of our algorithm. And we would end up deciding, based on our chain of reasoning, X must be true. And then the next day, we'd come in and Christian would say, hey, Y must be true. Except Y directly contradicted X. And that really threw me for a loop. I'm like, what? But we just said X was true. Okay, so I didn't realize that I was making this subconscious assumption that X was some kind of a spec. What it really was our best hypothesis at the time. So I recently came across this really fascinating book called The Half-Life of Facts. And it really underscores this idea from science that that science is not itself necessarily arriving at the truth, at any time, it's approaching the truth. And so we want science to build us better and better models that more accurately predict the world. So the fallout from that, though, is if we're always improving the model, something we used to think was true is no longer true. So facts change over time. The summary of that idea is that if you want to grab hold of the truth, you have to let go of a lot of untruths in the process. Okay, so I'm going to tell you a little love story here. This is me falling in love with an idea that I had, a hypothesis, and it was hard to say goodbye to. So we needed to build something that would give us insight into what our experiments were actually doing, right? What is this algorithm doing? And so my hypothesis was, aha, we need this app that will present dashboards and have real-time streaming data coming into them and wonderful visualizations. So I kind of built this whole fancy thing. By the way, if you have any curiosity at all about using Scala in the front end, I did a talk about this app at Scala by the Bay. There's a link down there. But anyway, there's really nothing wrong with this app except for the fact that where we were at, the facts were still kind of oscillating way over here, right? We didn't have a good fix on the type of data we even needed to collect or the type of visualizations we even needed to build. And so what it came down to was it added a whole bunch of friction to the process of testing our hypotheses. And so finally, I admitted this was too heavyweight. And the low-tech compromise kind of was embarrassingly obvious afterward. It ended up being, well, let's just put out some HTML files and some SVG files and link them all together and open it in the browser, right? You would not recognize this in any production setting. This doesn't scale. But for our purposes, it was great because we could move much faster that way. So again, if you have an idea, you start building on that idea, the more that you've built on top of it, the harder it's going to be to admit that you're wrong. This is a really, really important point. So I'm really going to beat it to death here by saying it in one more way. And this is really kind of, in my mind, a guide to help understand when it's time to start exploring. If you need to add complexity in order to refute contrary evidence, so you have an idea and you need to add more and more complicated assumptions in order to keep down these contrary evidence to your hypothesis, that's the point at which you want to apply Occam's razor. How many of you guys know what Occam's razor is? Okay, almost everybody, good. But it's a very simple idea, which states that if you're choosing among a set of hypotheses to explain some phenomenon, choose the one with the fewest assumptions. And so it's always good as an anchor point to step back, look at the hypotheses in front of you, and see whether any other ones that are not the one you chose make more sense. So that's kind of the mindset piece of it. But you also need some workspace. And I think what it comes down to is what kind of tools you have available. We've all heard this old saying, when the only thing you have is a hammer, everything's going to look like a nail. So I'm going to add a corollary to that, which is, let's say that you add a screwdriver to your toolbox. Now all of a sudden, you can tell the difference between a nail and a screw. So what that tells me is that the tools you have in your toolbox actually shape the way that you see the problem. So I think it's probably easy to think about some kind of feedback loop between the hypotheses you have and the experiments that you run, right? You might run an experiment, it gives you new information, and that leads to a new hypothesis. Well, tools, I think, are the third leg of this cycle, because the tools that you have shape how you see the problem, And they also, of course, enable experiments. So what's a good way to think about tools? I mean, for us, it's a library that we share. And I've come to think of it really as an index of the knowledge that we've acquired in our space. And once I realized that, I became a lot more comfortable with what I used to think was dead code. Because in production, dead code is a huge distraction. But when it comes to equipping your laboratory with tools, unused tools are just tools that you can apply to some problem in the future, right? That maybe you're not using them now, but it's a reminder of what you know. So the tools themselves need to be versatile. You don't want to fashion them for a single experiment. And the other thing is, don't over-engineer them, right? If you're really kind of in this early stage where facts can change rapidly, you know, it's okay to print to console. Just to give you an example, we had to create some bar charts of categorical probability distributions, and my first instinct was, oh yeah, we'll put it into some PNG or whatever, use a library. But Christian was like, well, why don't we just do ASCII art? You know, like there's these Unicode characters that have different heights, filled in boxes, and we can print bar charts to the console. You know, it works great. So we're using Scala, so we have the advantage of types, right? We started out with a set of very primitive operations. Because we're dealing with math, it ends up being a bag of numbers, right? We've seen a lot of mathematical libraries that kind of have this bag of numbers approach, like MATLAB or NumPy, right? What do these numbers even mean? And we had to interpret those, and I found it really a high cognitive load to try and interpret what they mean. So we started adding types that would define what types of numbers can interact with other types of numbers. So the types kind of acted as an instruction manual for the tools. So that's the tools, but what does our workspace look like? Well, first requirement is the tools need to be within arm's reach. We want the setup to be as little as possible so we can get right to testing, and we don't want to have a lot of distractions. So depending on, what technology you're using, the details might be different, but I kind of think of it in terms of these 3 tiers that depend on what type of test you're running. Are you trying to just do something quick and dirty and try something out within a couple minutes? In that case, hopefully you're using a language that has a REPL available. If you are trying to do something that's still lightweight, but maybe something you can reuse a little bit, takes a little more time, hopefully your language has scripting. And then, of course, if you're doing an ongoing project, perhaps even collaborative, then you do want a full-blown build system. Okay, so what about working on a team? That also needed a little bit of tweaking in order for us to be most effective. So getting back to David's talk where he mentioned the fixed idea, right? That if you have one idea, it's going to get in the way of other ideas, right? Imagine back 150 years, we didn't know how to build flying machines. And there was a set of perhaps equally plausible sounding hypotheses on how to go about building flying machines. So what if somebody had said, look guys, let's focus our efforts and work on this form factor, and let's tweak our design based on that. I can guarantee you we never would have come up with flying machines. So requiring the whole team, when you're this early on, to be in one code base, rather than kind of expanding the search space, it's limiting your options. So in other words, it downplays the level of ambiguity that you're dealing with. It's saying, this is right, and nothing else. Okay, so here's another side effect of having everybody on the same code base, which is you're probably going to be doing code reviews. And if you're doing code reviews, then you're going to be talking about code. how much white space should we put in here, or where should the curly braces go, or things of that nature. So the discussions are all about how we're going to do it when the what hasn't even been figured out. So for me, not requiring the code to merge into one branch allows our communication bandwidth among the team to focus at the higher level. So in terms of what to share, hypotheses, we should absolutely share those among the team. And the good thing about doing that is that your teammates want to sound smart, so they will not be able to resist the temptation to perform on-the-fly thought experiments and poke holes in your hypotheses. And the ones that end up surviving that discussion are the most plausible. Now, even if you disagree with your colleague and say, no, I think this could be right, that's okay too. You don't have to come to a consensus. You can say, all right, I'm going to go test that myself and see if this actually will work. You should absolutely share tools, right? Getting back to this idea that your tools are this index of what you know, share that index with your colleagues, because you might see a tool that you don't have a use for. When you share it with them, they might go, oh yeah, it'll solve that problem that I had. And then in terms of converging on something that you're ultimately going to build and put into production, you want to share requirements as they become clear, right? If you have hypotheses that you can no longer break despite collective effort, those start to become your requirements. And when you have enough of those that don't completely shatter within, say, a few days, you can probably start putting together a project plan. So I'm going to switch gears a little bit and talk about just the setup that I think is needed in order to be creative. And this is kind of inward focused. So the first observation that I want to make is that creativity and execution are two different modes, because your brain needs to be in conflicting and different states in order to execute, follow a plan, versus being creative, right? One involves kind of narrowing the options. The other one involves expanding the options. I've tried to be in both at once, and I've still been trying. Even during this conference, I thought, oh, I'm going to set aside a few hours and do some creative problem solving. My mind was not in the right mode. So it's a lesson that I just need to remind myself of over and over and over again. So I want to point out where these two modes fit in with kind of this exploration process that I've described. Both of them are necessary throughout the process, and you're going to continually go between them. So formulating hypotheses would be largely a creative effort, whereas testing them, yes, it's also creative, but it also has some aspect of execution, because perhaps I know what I'm going to do, and I'm going to write the code. Same thing with building tools. So it's not strictly stuck in these categories, but you kind of get the idea. So I'm going to bet that you guys are pretty familiar with execution mode, and maybe slightly less familiar with creative mode. So I'm going to spend the rest of the time talking about creative mode. So we've all heard the story, probably, of Isaac Newton sitting under the apple tree, and the apple falls down, and he goes, aha, it's gravity. I mean, what a wonderful story, right? What a magical moment described by this story. And similarly, we might have had experiences where our colleagues come up with some pretty amazing insights. And, I've had this experience where I wonder, gee, they must have something that I don't. How are they coming up with this, and why am I not coming up with this? Well, the problem is that the stories that we all love keep the boring parts out. So Thomas Edison had famously said that genius is 99% perspiration, 1% inspiration. The problem is the red part of that circle is a super boring story, and the white part is the magical, exciting one. So the good news is it's not some special thing that certain people have and other people don't. The thing is, we need to structure our day or our time to best do that work that leads to creative insights. So what doesn't work, first of all? Creativity doesn't really like management. It's hard to put up a project plan that says, hey, by the end of May, we're going to have, solved X, Y, and Z, right? It doesn't stick to a schedule either. You can't really force yourself, okay, by Friday, I'm going to have 10 creative ideas. So you can't really manufacture it, but you can cultivate it, right? Think more like you're growing a garden. And I've kind of found that there's a few ingredients that end up really helping with this process. I won't say this in an exhaustive list, but it's really been a big game changer for me. So nourishment, exercise, and rest. And you're probably thinking about the body right now, eat well and exercise and sleep. Well, this isn't a health class, so I'm not really going to talk about that. I'm going to talk about how to get these things for your mind. So I think the best way to think about it is how you structure your time. And this is kind of a schematic of an ideal day of being creative. So I say ideal because this is not exactly realistic to do this every day. I just want you to get a flavor for how you might fit in these ingredients for whatever way works for you. So let me break it down for you. The first ingredient, exercise, is really what we classically think about when we think about creative problem solving. You're sitting there with your notebook and you're writing down ideas or you're whatever it is. So this is the time you're actively working on the problem. And I found that the Pomodoro technique is a fantastic one for doing this. How many of you guys have heard of the Pomodoro technique? Okay, just about everybody. How many of you use it? A few. Okay. So hopefully this will inspire you to use it again. The features of it, it's very simple, right? 25 minutes, you identify your problem, you focus on it, 5-minute break, right? The features of it are that the goals that you set are not based on the outcomes you want to achieve. It's based on how much time you spend. And that's an incredibly liberating concept. The second one is it gives you permission to take breaks. I don't know about you, but if I'm working on a hard problem and I haven't solved it, my first instinct is to dig in and think really hard to solve that problem, as opposed to walking away, which is what I should really be doing. So the key thing about the rest period is that it's long enough, you can get up, stretch, have your glass of water, but it's not so long that you can get distracted by other things. And of course, the timer helps motivate you to avoid distraction. There's only 10 minutes on the timer, so if you really need to check social media, you can do that in 10 minutes. And then the other thing is it ideally sets you up with a daily quitting time. So you can say, I quit every single day, which is much more liberating than you might imagine. So the other piece of exercise, this is kind of both exercise and rest, and this is really kind of switching modes of thinking. What I described with the Pomodoro technique is really focus mode. You're staring at an individual blade of grass, working out what's going on there. But what if you're staring at the wrong blade of grass? That's when you need to pull back and let your thoughts bounce around more broadly, because that's when you make connections that you would never make by thinking really hard. So this concept comes from a pretty amazing course that I took from Coursera. It's called Learning How to Learn. And so the basic idea is you want to make sure that there's several periods in your day where you're switching between focused and diffuse mode. So this is how I do it. I have a dog, so I take him outside and walk the dog because I work from home some days. And so that outdoor exercise really kind of takes my thoughts into a more expansive form. And oftentimes when I'm stuck, it'll get me unstuck. And if it doesn't, at least my blood pressure is lower when I come back. So now we're going to talk about rest. You've all probably heard, sleep is important, you have to sleep for all these various reasons. So let me give you one more reason why it's important. Over the course of the day, you're accumulating stuff in your short-term memory. You're accumulating your experiences in a very unfiltered manner. It's not exactly a videotape, but the essence of those experiences hasn't been distilled. That memory that you're building up is incredibly complex. So many things going on. But what you really want is a much simpler model, insight. As you get older, you kind of have an idea of the rhythm of the days, and you remember individual days less and less. Well, that's the result of having this simpler model. So how do we get from here to there? It's this process called sleep. So here's the thing about sleep, though. You only do it for so many hours a day. So think about the fact that you only have so much capacity to reduce your model complexity that leads you to that insight. Which brings me to my next topic, which is nutrition for your mind. And I found that mental nutrition is more about what you don't put in your mind than what you do put in your mind. Right? There's all kinds of distractions that we love to partake in, and we kind of, I often think, oh yeah, I'm getting a break, I'm playing some stupid game on my phone or whatever, right? I'm getting a mental break. But unfortunately, no. What happens is that these distractions build up in your short-term memory, which then reduces the ability for your mind to process the complexity of the problem you're trying to creatively solve. So, I can't say, oh, don't ever, do anything distracting, but I can say it's incredibly beneficial to limit when you do that during the day to a very specific time. So just to wrap up, kind of summarize what we talked about. In the beginning, act like a beginner. So if you're coming at something, you might be an expert in one thing, but just forget that you are. Don't be afraid. Just build the embarrassingly simple version first. You want to optimize for hypothesis testing, right, when you're getting in this exploratory mode. Facts can change. This always is the case. We just feel it more when we're exploring. So I would hope that this would start to seep into sort of more everyday work. And remember, when you're exploring, think about how you're working in a laboratory, not necessarily a factory, so get it well equipped. And then think about what level you want to interact with your colleagues on. Keep it at the high level at first. And then lastly, creativity is not something we can make happen, but we can cultivate it. So recognize when are you in creative mode, when are you in execution mode, and give yourself the right conditions for creativity. So taking a big step back, I'm guessing that most of you came here because you're curious. You want to explore. You want to take in new ideas and new technologies. So I hope this talk has given you some food for thought to take these ideas, these sparks that might be there, and turn them into a raging fire of exploration. So please give me a rating, and thank you for your attention.